Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, Calbepedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Okay, this is the final section for the chemical formulae and equation. Okay, we've done chemical formulae, symbol, and equation 1, 2, 3, and this is the final one, which is 4. I guess you've been following up for you to get the detailed knowledge and the detailed information you need on chemical formulae and equation. Now, by the end of this lesson, you will be able to know the difference between molar mass and molecular mass, relationship with masses and mole, how to balance the chemical equation, and information shown by chemical equations. Now, difference between molar mass and molecular mass. The molar mass is the mass of the Avogadro's number of a substance, while the molecular mass is the sum of all the atoms present in a compound. Now, the molar mass, like I said, is the mass of the Avogadro's number. In essence, it is the number of moles. It is the number of moles in the mass of a substance. It is the mass number. In essence, it is the mass of moles. The mass of moles. Avogadro number is a mole. Okay, every Avogadro number of a substance is the mole of that substance. In essence, this substance can be an element or a compound. Okay, now the mass of these moles becomes the molar mass, while the molecular mass is the sum of all the atoms present in the compound. Every single atom that is present in a compound becomes the molar mass. Okay, becomes the molecular mass. Sorry. Why? Because it is the number of molecules, it is the number of atoms that is converted to the number of molecules. In essence, when these atoms make up molecules, they become molar masses. Take, for example, we have H subscript 2, SO subscript 4, which is sulfuric acid. Okay? The molecular mass of this compound will be the mass of hydrogen plus the mass of sulfur plus the mass of oxygen. In essence, it's the sum of all the atoms. Okay? All the atoms present. Okay? In this compound will become the molar mass. While the Avogadro number will be of each element. Each element. In essence, the molar masses talks about each element, the number of each element, number of moles in a compound, while the molar mass talks about every single mass of the element in a compound. Now, the next one, relationship between the mass of a substance and a mole. Now, substance and its formula, we give oxygen. The type of particle is atom. Why? Because there is no number of atoms present in the oxygen. The oxygen becomes an atom. But if there is any subscript attached to an element, it becomes a molecule. If there's any subscript attached to an element, it becomes a molecule. But if the element is the element is just being placed as a single element, it becomes an atom. Okay? It has one atom inside. The molecule has one atom inside. But if there is a subscript, that means the molecule has two atoms inside. But if it is placed as a single element, the type of particle present in that element is an atom. Remember, I told you every element is a molecule, but not all molecules are elements. In essence, the number of atoms in this particular element, in this particular molecule, is 1. So in essence, it is tagged as an atom. Now, if you check the type of particle of oxygen as an atom, is an atom. Now the mass of substance is 16. In essence, all the masses, whether formula mass, molecular mass, molar mass, every single mass of this oxygen is 16. Why? Because oxygen has a mass number of 16. So any type of mass you want to call it, formula mass, molecular mass, molar mass, as long as it is tagged mass, oxygen is 16. And we know that the mass number are the number of protons and neutrons in one molecule of an element. Now the mass of mole is still 16. In essence, the moles, the Avogadro's number, the mass of the Avogadro's number and the mass of the substance are the same thing. So if it has a mass of 1 mole, mass of 1 mole will be 16. The mass of 2 moles will be 32. In essence, the mass of a mole is the mass number of an element. The mass of 1 mole, the mass of 1 mole is the Avogadro's, is the mass of the Avogadro's number of the element. So if the mass of a substance is 16, that means the mass of 1 mole will be 16. Now the next one is oxygen molecule. As you can see, it has a subscript. In essence, it is a diatomic molecule. Di there, the 2 there represents, the 2 there represents di. In essence, it has 2 atoms in the molecule. So it becomes a molecule. Now the mass of the substance is 32. Why? Because the number of atoms to be multiplied by the mass number to give it the mass of the substance. We did that in chemical formula 3. Chemical formula equation 3. How do we get mass numbers of elements? If there is a number of atoms, you times it by the mass number to get the mass, the molar mass of the substance. Now the mass of 1 mole is 32. Why? Because the mass of that substance becomes the mass of 1 mole. In essence, the mass of a substance is directly proportional to the mass of 1 mole. The mass of every substance is directly proportional to the mass of 1 mole. Directly proportional means equal to. It varies. It is the same thing of 1 mole. Now the mass of 2 moles of the substance will be times 2 of that substance. Will be times 2 of the mass number of that substance. Remember, the mass of the substance is 1 mole of that substance. So 2 will be times 2, 3 will be times 3 of the mass, 4 will be times 4 of the mass, according to how it goes. So sodium ion is the next one. The particle there is an ion. Why is it an ion? As you can see, there's a superscript plus. That plus signifies a charge. And we know that every charged body is called an ion. So the mass of a substance of that is 23. Sodium is 23. That's the mass. So the mass of 1 mole will still be 23. The mass, like I said, any type of mass you want to call it, whether formula mass, whether molar mass, molecular mass, every mass is the same for every element. Now hydrochloric acid, okay, hydrochloric acid or hydrochloride is a molecule of 36.5. That's the mass number. Why is it 36.5? Hydrochloride or hydrochloric acid is a compound. So for you to get the mass of a compound, you must have to add the masses of the elements that make up this compound for you to get the mass of a compound. Now if you check, hydrogen has a mass number of 1 and chlorine has a mass number of 35.5. Adding it together gives us 36.5. And this 36.5 as the mass number is still the mass of 1 mole. In essence, I told you that Avogadro's number is the number of moles in a compound. So the mass of the Avogadro's number is the number of particles in a substance. That's the Avogadro's number. Number of particles. In essence, every 1 mole identifies the mass number of a substance. Every mass of 1 mole is the mass number of a substance. Now, ammonia is a molecule. Ammonia is a molecule that has a mass number of 17. Mass number of 17, and the mass of 1 mole is 17 grams. The mass of 1 mole is 17 grams. Why? Because nitrogen has a mass number of 14. Hydrogen has a mass number of 1. Adding up to the number of atoms present, which is 3, is going to give you 4. So 13 plus 4 is 17. And the mass of 1 mole of that will still give us 17 grams. So in essence, I told you every 1 mole of an element is the mass number of that element. So if it has 2 moles, it will be times 2 of the mass number of the element. If it has 3 moles, then it's times 3 of the mass number of the element. Now, valency, so they call valency. Okay, after you got this thing, you got to know what valency is. Valency is the property of an element that determines the number of other atoms with which an atom of the element can combine. In essence, it talks about the combining power of elements. Valency or valence. Valency is British, valence is American. Okay, they mean the same thing. Valence. When we talk about valence electrons, okay, when we're talking about the particles of matter, we talk about valence electrons. Okay, those electrons that surround, that goes around in an orbit out in the outer shell of an atom. They're called valence electrons. Now, it's the property of an element that determines the number of other atoms with which an atom of element can combine. Now, other atoms come together. Okay? Now, in the element, what comes together to make a compound is the atoms that come together in the element. That is why you see the element remains the same. I see the number of atoms still remain the same. In essence, atoms and molecules are catalysts, because they take part in reactions and they remain the same. The atoms take part in reactions and remain the same after the reaction. If it's 2 atoms that took part, it will still be 2 in the compound. And that 2 will relate with another to form a molecule. And those molecules will now be the smallest portion of a compound. So the property of an element that determines the number of atoms with which they can combine is called valency. Now, I said it is the combining power of elements. The combining power of elements. Which power does this element possess in combining to make a compound? In essence, this particular combining becomes a valence or a valency. Now, NB, I said note, the number of moles of hydrogen atoms that combines with 1 mole of an element gives us the valency of that element. Take, for example, the number of moles of hydrogen. Okay? Number of moles of hydrogen gives us the valency. Like hydrochloric acid. The number of moles of hydrochloric acid there is 1. If you check out, hydrogen is 1. So the valency of hydrochloric acid is 1. So the valency of chlorine there is 1. If you check the one in CH subscript 4 with the methane, the valency of that is 4. If you check HF, hydrogen fluoride, the valency there is 1 because hydrogen is 1. If you check ammonia, the valency there is 3 because hydrogen is 3. So the number of moles, the number of atoms that is present in hydrogen gives us the valency of that particular element. So the valency of nitrogen will be 3. Why? Because it was 3 moles of hydrogen that reacted with nitrogen to give us ammonia. So every single number of atom or moles, okay? I call it moles because it has formed a compound. When it comes in a compound, it's no longer atoms, it is being called molecules or moles. Okay, so, but I want to expatiate it very well for you so that you understand what I said, what I'm saying. Now, I said 3 for hydrogen become 3 atoms of hydrogen. Now, when it reacts with nitrogen, it becomes 3 moles of hydrogen. Now, that 3 moles of hydrogen becomes the valency of nitrogen. Because if hydrogen reacts with an element, the number of moles becomes the valency of that element that it is reacting with to form the compound. Now, radical. Radical is an atom, molecule or ion that has an unpaired valence electron. They have the unpaired valence electron. Now, most of these particular substances that hydrogen is reacting with are gases. They are gases. So they have unpaired valence electrons. Why? Because they already have electron. Why do you have electron? Because they are negatively charged. They are negatively charged. And that is why hydrogen can be able to react to them. Hydrogen is both positively charged and negatively charged. Now, when hydrogen reacts with these non-metals, with these gases that have negative charges, what hydrogen gives out is its positive charge. And that positive charge becomes the valency of that particular element. Why? Because hydrogen needs to sacrifice its positivity for the negativity to be attached for that compound to be formed. What do I mean? Hydrogen is giving out its 3 to nitrogen. In essence, when it gives out its 3 to nitrogen, they form ammonia. Okay? And it's subscript 3. When it gives us its 3 to nitrogen, let me give you an illustration. Take, for example, NH3. NH3. Now, hydrogen will give its 3, will sacrifice its 3 to nitrogen. Hydrogen will sacrifice its 3 to nitrogen to form ammonia. Now, when it sacrifices 3 to nitrogen, that is only when a compound can be formed called ammonia. Now, as it gave this 3 to it, as it gave this 3 to nitrogen, he has sacrificed it. He is now left alone. He has given his 3 to nitrogen. He is now left alone. Now, nitrogen will now take the 3 so that they can be able to form something that is called ammonia. Now, this 3 he gave to him will now react with the electron that he has. Nitrogen is a gas. So in essence, it is a non-metal. And non-metals are negative in nature. They have electrons. They have valence electrons. They don't pair. They don't give out. They only receive. They don't give out. They only receive. These radicals. They don't give out. They only receive. So now nitrogen has received the 3 from nitrogen to form the ammonia. In essence, the nitrogen, now the valence of nitrogen will become 3. Why? Because he took this 3, he took the 3, he did not lose. In essence, he collected and added to himself. Now that's what he collected to himself becomes the valence of what is being known for. So now nitrogen becomes a radical. Why? Because he did not give out any valence electron. There is nothing he gave out. Okay? There's nothing he gave out. In essence, he received. So those elements that receives, that do not give out their electrons are called radicals. Are called radicals. Now, balancing of chemical equation. Balancing of chemical equation. I told you that compounds are formed. Okay? Now, there are compounds that you need to know, and there are things that form this compound. Okay? A compound has 2 phases. An equation has 2 phases. Okay? It has the phase on the left and it has the phase on the right. Okay? Now, compounds can still be reactants, and compounds can still be products. In essence, if the reactants are not basically represented correctly, it must have to be balanced. It must have to be balanced. Now, let's know what a chemical, before we know that, we know what the chemical equation is, before you can know how to balance a chemical equation. A chemical equation is a symbolic representation of a chemical reaction in form of symbols and formulae. When you represent a chemical reaction with symbols and formulas, it becomes a chemical equation. Like, take for example, I represent water. Okay, I like using water. This is, or let's say, let's use this one, 2 molecules of hydrogen reacting with 2 to give us 2H2 subscript O. This is G, and this is G. I told you in the last chemical equation that this thing is steam. When 2 molecules of water, it becomes steam. Steam. This is the formula for steam. Okay? Now, for every 2 molecules or 2 moles of hydrogen, water is formed. And for every 1 mole of oxygen, water is formed. Now, this is a we say its chemical equation is a symbolic representation of a chemical reaction in form of symbols and formulae. We've symbolized hydrogen as H. We've symbolized oxygen as O. We symbolize water as H subscript 2O. Now we have represented this. Now, this particular thing took place is a reaction because hydrogen and oxygen reacted and the product was steam. Water in a gaseous state. Water in a gaseous state is called steam. Water in a gaseous state is called steam. In essence, steam is a liquid in gaseous form. Steam is a liquid in gaseous form. Now, this thing has been represented with symbols and formulas. Okay? Now, the symbol of hydrogen is H. The formula for the hydrogen molecule is H subscript 2. In essence, we represented this equation is an equation because there's a transformation from gas, there's a transformation from hydrogen and oxygen gave us water. So there's a transformation. The hydrogen and oxygen are transformed to another generation. So when this is done, it's called a chemical equation. Now, what is balancing of a chemical equation? Balancing of a chemical equation is the process of using mathematical entity in making the number of atoms and molecules equal on both sides. Remember, I told you an equation has both sides. An equation has both sides. It has the left and it has the right. If you check, this is the left and this is the right. Okay? Now, the left are the reactants and the right is the product. So you're going to use mathematical entity making number of atoms and molecules equal on both sides. They must have to be equal on the right and equal on the left. Now, if you see here, this is a balanced equation because it is equal. This is 4, this is 4. Oxygen is 2 and oxygen is 2. So it must have to be equal. That is the process. As you're writing the numbers, the integers, and balancing in the equation to balance it is called balancing. ING is a continuous process. So you're going to be balancing until you get to the balanced. You're going to be cooking until the soup is ready for us to chop, or for us to eat, or for us to swallow. So that process you're using is cooking. Then when the food is ready, the food has been cooked. Boom, constant. So when you're using mathematical entities, using numbers to make this number of atoms and molecules the same on both sides, it's called balancing of equation. Now, what is a balanced equation? What is a balanced equation? A balanced equation is an equation whose coefficient result is equal. Whose coefficient result in equal numbers of atoms for each element in the reactant and the product. A balanced equation is an equation whose coefficient result in equal numbers of atoms for each element in the reactants and the product. In essence, the number of hydrogen at the left will be the number of hydrogen at the right. Number of hydrogen in the middle and the number of oxygen in the left will be the number of oxygen in the right. I give you an example of this. Okay? I give you an example of this. Now, if you check, hydrogen here is 2 times 2, which is 4. Hydrogen here is 4, if you check. Oxygen here is 2. Hydrogen here is 4. 2 times 2, 4. Hydrogen is 4 here. Then oxygen is 2 here. And oxygen is 2 here. Why? Because these 2 as a molecule will affect every single compound. The 2 is affecting the full compound. So in essence, affecting the full compound, hydrogen will be 2 times 2, which is 4. And oxygen will still be 2. So it is 2 here as an atom and 2 here as a molecule. So it is the same thing. Now, we want to balance an equation. We want to balance an equation. Next one, rules on balancing an equation. They say write down the given equation, first of all. When you write it down, they say write down the number of atoms per element. How many atoms are present in the element? You write it down first. Then save hydrogen and oxygen for the last. You don't touch hydrogen and oxygen. You save it for the last. Okay? That's the last thing you're going to save. Remember, when we are talking about, I know I was talking about, is it in chapter 1 of chemical symbol and formula, or chapter 2, when I was talking about rules of writing a compound from, rules of writing a compound, rules on writing formulas from compounds. I told you oxygen comes last. So the oxygen comes last when you want to write a formula for a compound. Okay? Now in the balancing of equation, they said leave hydrogen and oxygen for the last. Then start with a single element. You can start with the first element. Okay, you start with the first element, or you start with any other element in this thing. Anywhere you want to start, you start. Then they say use the coefficient to balance the single element until balanced. That element you started with, balance it with a coefficient. In essence, balance it with numbers. I told you balancing of an equation is using mathematical entities, mathematical numbers. Okay, when you see that this particular one you started with is balanced, then you go to the next one. Then you balance hydrogen atom next. When you finish, then the last one is balance the oxygen atom. Now, you've known the rules of balancing an equation. Now, we are going to take an equation to balance. Okay, we are going to see how to balance an equation. Since the rules is being laid out, we'll follow the rules in balancing an equation. Now, the first one says write down the given equation. Write down the given equation. Now, let's write down the equation. The equation given is C subscript 3, A subscript 8, and O subscript 2. Okay, C subscript 3, A subscript 8. Okay, sorry. C subscript 2, O subscript 8, O2 gives us H subscript 2O, CO subscript 2. Now, the second rule says write down the number of atoms per element. Remember, this equation has two sides, the left-hand side and the right-hand side. Okay, so you're going to share it into two and writing the number of the number of atoms per element on the right, and writing the number of elements and writing the number of atoms per element on the left. So you're going to share into two. Now, carbon here, C here is 3, H here is 8, and O here is 2. Coming to this place, you see H here is 2, O here is 3, and C here is 1. Let's take it the way we wrote it on the left. Let's take it the way we wrote it on the left. We wrote C here as, C here is 1, H here is 2, and O here is 3. Why is O 3? Because there's one oxygen here, there's one O here, and there are two O's here, and there are two oxygen here. In essence, the oxygen here 1 plus the oxygen here 2 gave us 3. The hydrogen here is 2 atoms. Okay? And the carbon here is 1. Why on the right hand side, the carbon here is 3, the hydrogen here is 8, and the oxygen here is 2. Now the issue is, the next one says save hydrogen and oxygen for the last. Fine. Then it says start with a single element. You do not touch hydrogen and oxygen. They say you save it for the last. Now the single element you have to start with is carbon. Now carbon here is 3 and carbon here is 1. What are you going to add to carbon that will make carbon here 3 and carbon here 3? Remember, you start with the lower. You start with the lower number. The lower number of atoms in an element. That's what you start with. Now, carbon here is 3 is greater than carbon here is 1. So in essence, you have to start. What are you going to add to carbon here that will make carbon 3 here and carbon 3 here? What are you going to add to carbon? I told you balancing of equation is usage of mathematical entity. In essence, you're going to use numbers in balancing. You just add numbers. to the elements so that they're going to become equal on the left and equal on the right. Now, if you think, what are we going to add? If we add 3 to carbon here, I think carbon will be 3 here and carbon will be 3 here. So we are going to add 3 to carbon here, that will make carbon 3 here and carbon 3 here. So in essence, the equation will be C3 H subscript 8 plus O subscript 2 will give us H subscript 2 plus 3 C subscript 2. In essence, if you see now, carbon is 3 here and carbon is 3 here. So you cancel this 1 and write 3. Since carbon is 3 here and carbon is 3 here. And you can see now carbon is now balanced. 3, 3. What we just added is 3. Carbon is 3 here. Okay? If you check here, carbon 2 is 3. Whether the number, whether the number is written together with the element or it is written at the base of the element, it is the same thing. In balancing of equation, it is the same thing. Okay? In the balancing of equation, it is the same thing. Because it is the atoms that makes up molecules. And the molecules are a combination of atoms. Now, they said, the next one says, balance the hydrogen atom next. Balance the hydrogen atom next. Now, what are we going to add to hydrogen? If you check, hydrogen here is 8 on the left, and hydrogen here is 2 on the right. What do we add to hydrogen that will make hydrogen 8 here and 8 here? I said you start with the lowest. Hydrogen is 2 here, hydrogen 8 here. So you're going to add a number to the lower number to make it equal to the greater number. Now, the lower number of hydrogen is 2 on the right. That's the lower number. So you're going to add a number to 2 that will make hydrogen the same with 4, with hydrogen on the left. What do we add? If you check well, what do we add? You look very well. What are we going to add? I think if we add 4 to hydrogen, it might be able to give us the same thing. Let's try 4. Let's try to use 4. Now, if you are using 4, it will be 6, 3, H subscript 8 plus O subscript 2. We added 4 here. Now, we adding 4 to hydrogen has given us 4 times 2 is 8 now to hydrogen. Here is 8 and here is 8. If you check, hydrogen here is 8 now on the left. Now, we added 4 to hydrogen here, and it gave us 8, 4 times 2. Remember, you're not dealing with the whole compound. You're dealing per element. It is per element you're balancing. Every element, that's what you're balancing. That's why they say you write out the number of atoms per element. It is the element that you're balancing. You're not balancing the whole compound, no. It's only the element you're balancing. Okay? So, we have balanced hydrogen as 8 here and 8 here. So you cancel the 2 and put hydrogen as 8. As 8. So next, hydrogen is 8 here and hydrogen is 8 here. Why is it 8? 4 times 2 becomes 8. Now, they said balance the oxygen atom last. Now let's check. Oxygen here is 2. Oxygen here is 2. Now, oxygen here is now, let's calculate oxygen here now. Okay? This 4 that is being placed here is going to affect every single element here. And this 3 will affect every single element here. As you can see. 4 times 2 for hydrogen. This 4 will still affect oxygen. Why? Because the oxygen and hydrogen are together. This 3 will affect oxygen. Why? Because the oxygen and carbon are together. They are together. But we are still balancing the elements individually. Okay? But during the balancing, any element that is together, during the balancing, any element that is together, the integer used on one of the elements affects both of them. In balancing, any elements that are together, the integers used affects all of them. So in essence, the integer used for hydrogen will affect oxygen. The integer used for carbon will affect oxygen. Now, if we calculate 4 oxygen is 4 here, plus oxygen is 6 here. Why? Because oxygen has an atomic number of 2 in this place. In essence, it has a subscript of 2, times it by 3, it will be 6. So oxygen is 6 here, plus 4 here, oxygen is 10 here. Oxygen becomes 10 on the right-hand side. Oxygen becomes 10 on the right-hand side. Like I said, why is oxygen 10? Because I said we are balancing per element, no doubt. But if an integer, or if a mathematical entity, or if a number is used on one of the elements, okay, if there are 2 elements, and a number is used to balance one of the elements, that number affects the both elements. That number affects the both elements. As you can see, we have hydrogen and oxygen, and we use 4 in balancing hydrogen. The 4 will affect oxygen too. Why? Because they are together. We use 3 in balancing carbon. The 3 will affect oxygen. Why? Because they are together. So now, the 3 times 2, oxygen has 2. So the 3 times 2 gave us 6. And here oxygen is 4. So this is 4 plus 6. Oxygen will now be 10. Oxygen will now be 10. Now, in the right-hand side. Now, in the left-hand side, oxygen is 2. I told you the smaller number of atoms is the smaller number of atoms is that one you're going to upgrade to become equal with the bigger number of atoms. If the smaller number is on the right, you upgrade the right to become equal with the left. If it's on the left, you upgrade it to the you upgrade the left to become equal to the right. Now, what do I add to oxygen that will make oxygen 10 here and 10 here? Why? Because oxygen is 10 already on the right-hand side. So the smaller number of oxygen is on the left-hand side, which is 2. What do I add to oxygen that will make it the same? If you check, in essence, what do you times by this oxygen? That will give you 10 here and 10 here. What do you add to oxygen? Oxygen is not 1, it is 2. Okay? This thing is basically on times. If you check carbon, carbon is 1 here. 3 times 1 is 3. If you check hydrogen, hydrogen is 2 here. What do you add? What do you times? What are you going to times to hydrogen 2 that will give you 8 and hydrogen left? It's just times. That's no big deal. Balance of equation is just, if you know multiplication, you're gone. Look at it. Carbon is 3 here, and carbon is 3 here. That's what we started. What do you add to carbon that will time? Because carbon is 1. What do I add, or what do I times with carbon? 1. 1 carbon that will give me the same thing here is 3. 3 times 3, 3 times 1 is 3. Fine. Now, you came to hydrogen. Hydrogen here is 8, and hydrogen here was 2. What do you times with 2 that will give you the same thing, 8 here? What do you times with 2 that will give you 8? So that it will be equal. We say it's 4. 4 times 2 gave us 8. Now, oxygen. Oxygen is 4 already here. And oxygen is 3 times 2, which is 6. It's times. 3 times 2, which is 6. Now, it has given us 4 and 6. Now, this is 10 here. Now, oxygen is 2 here. What do I times with 2 that will give me 10 with the same, so that it will be the same as oxygen on the right? What do I times with 2? You already know. So it will be C3, A subscript 8 plus. What do I times with it? Is 5. So if you check, Now, the balanced equation is this is the balanced equation. Why? Because if you check, carbon is 3 here, and carbon is 3 here. 3 times 1, 3. Hydrogen is 8 here, and hydrogen is 8 here. 4 times 2, 8. Oxygen is 10 here. 5 times 2, 10. And oxygen is 10 here. 4 times 1, 4 times this one oxygen, plus 3 times plus 3 times 2 oxygen here, which is 6, and that is 10. So this is the balanced equation. These are the balanced equation. Okay, you add numbers that you can times with the atoms to give you the same number on the bigger side. That is how the balanced equation. So this is the way they balance an equation. As you can see, it's being placed on steps. It's being placed on steps. So this is how they balance an equation. You look for non-integers. You look for numbers that you're going to use in timesing the number of atoms, in timesing the number of the smaller number to make it equal with the bigger number. If the smaller number is on the left and the bigger number is on the right, you look for a number that you times with the smaller number. Okay, as you can see we did here. We look for numbers that we use in timesing the number of atoms that every single element has. That will make it equal with the next element for it to be the same. Now, information provided by chemical equation. You can see the chemical equation here. This is the chemical equation, the balanced equation. It shows the component element involved. The component elements involved are carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. Okay? It shows the products involved in the reaction. These are the products. The left-hand side and the right-hand side, these are the products, water and carbon dioxide. This one and oxygen, these are the products. Now the other one is saying it gives a picture of the movement of elements involved in the transformation. If you check, this arrow signifies the movement. That arrow signifies the movement. In essence, the transformation has been made from here to here via the arrow, which is the movement. The elements have moved, okay? And as they move, some of them change their states. As they move, they change, some of them change their states. Like carbon and hydrogen here came here, carbon and oxygen here came here and gave us water. So some of them change their states as they move. So the picture it shows to us. It exposes the relationship between the amount of products and reactants. Now this is the relationship. They have a relationship. The hydrogen and oxygen has a relationship and gave us water. The carbon and oxygen has a relationship and gave us carbon dioxide. So they show this relationship. They show how they bond together. They show how the breakage of bond is. And they show the characteristics, the state of matter in which the substances are present. Okay? We have seen that this is water, liquid. It shows us that water is a liquid. It shows us that carbon dioxide is a gas. It shows us the states of matter. As you can see, H2O is a liquid and the carbon dioxide is a gas. It shows us the type of matter. In essence, the type of matter that this thing formed was water and gas. Was liquid and gas. Now, the information that it does not show, information not shown by chemical reaction. One, it does not show the speed of the reaction. Because what you do is just a writing. Speed is what you see. Okay? The chemical reaction is just being shown. The chemical equation. Okay, it's an equation. It is the chemical reaction that shows the speed of a reaction. Why the equation just write out. The equation is just an illustration of what the reaction has finished. So it cannot show you the speed because it's a fixture. Okay? It's a fixture. Now the color of the substance, it cannot show you the color. It cannot show you, like look at the thing on the board, there's no color. We don't know the color. The only color you're seeing on the board is the color of my marker. That's the only color you're seeing on the board. So it does not show you the color. All what it show you is that it's a liquid. What is the color of the liquid? You don't know. So the next one is the heat change during the reaction. There is no heat applied on the chemical equation. It is a reaction that brings out that shows the heat Okay? Why? Because this chemical equation is just an entity, it's just a writing. It's just what? A writing. Now we've come to the end of this section, but before we leave, like I said, we'll use our exam guide in quantifying what we have learned so that we can be able to understand the information that we have gotten. To understand the information that we have gotten. So we'll go to the exam guide, 2013, question 19. Question 19 says, consider the reaction represented by the following equation. The value of y is the value of y in the reaction is. Now, when you check this consider reaction, in essence, they're trying to tell you that this particular equation, you must have to know how to balance it. Okay? For this equation to be balanced, they're telling you to know, to tell us the y, so that the equation will be balanced. Now, if you check this equation, the equation has two phases. It has the right and the left. Okay? They say the C subscript 2, H subscript 2 plus Y, H subscript 2 gave us C2, C subscript 2, H subscript 6. Now, if you check, the carbon is 2 here, and the carbon is 2 here. Okay? Hydrogen is 2 here. Hydrogen is 4 there. And 4 on the left, and hydrogen is 6 on the right. Now, in essence, hydrogen is not complete. Hydrogen is not complete. Okay? The hydrogen is not complete. Now, the Y there say, now, if your hydrogen is not going to be complete, you're going to balance the hydrogen on the left, because the hydrogen has a lower version on the left than on the right. Now, what are you going to times with 2? What are you going to times with 2? That will make the hydrogen the same on the left and the same on the right. If you check that Y there, what are you going to times with 2? That Y signifies what you're going to times with 2 that will make hydrogen the same here. And if you check, 4 times 2 will give you 8. In essence, hydrogen will be 10 on the left and 10 on the right. Why? Because that Y is 4, the 4 times 2 will give you 6. Will give you 8, sorry. Then the hydrogen that is 2 there will still give you 10. That is 10. If you use 3, 3 will be 3 times 2, 6. Plus the 2 will give you 8. But if you use 2, 2 times, that Y as 2, it will be 2 times 2, it will give you 4. 4 plus the 2 for the first hydrogen 2 will give you 6. Now, if hydrogen is 6 on the left, and on the right, you see it is C subscript 2, H subscript 6, that means to say Y will be 2. And that Y is what makes that equation balance. So in essence, Y is 2. So the answer is 2C. Now, there's one, this now I want to tell you, one secret. A balanced equation, sorry to say this, a balanced equation is based on the law of conservation of mass. A balanced equation is based on the law of conservation of mass. And what they said, matter can neither be created nor destroyed. That's the balanced equation. Now, if you check this equation, it is not created and is not destroyed. You cannot destroy it. Because when it came to here, when you balance an equation, as you can see, it wasn't destroyed. It was only balanced. You only balanced it. You did not destroy it. Okay? You only made the left-hand side of the equation. You only made the reactants and the products equal. You did not destroy it. You didn't destroy it. It cannot be destroyed during a reaction. It can never be created or destroyed during a reaction. Now, if you check these reactions, they are not destroyed. The reactions here, they are not destroyed. What we did, we just used mathematical entities to balance this equation. In essence, we can't be able to destroy it. We did not destroy it. We have to make it balanced so that it is going to be equal and give us a tantamount chemical equation. So the balanced equation is based on the law of conservation of mass. And states that matter can neither be created nor destroyed in a chemical reaction. That is the principle of the law of conservation of mass. I told you the law. So this is the principle of the law of conservation of mass. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.